Welcome back, ladies and gentlemen. And let's focus now on the second part of our track 2 of this afternoon session. And we'll look now at knowledge graphs. And to open this particular topic, it's a pleasure to welcome Christophe Debruyne, who is from the Montefiore Institute at the University of Liège. And Christophe will take us through the use of knowledge graphs and SHACL, which was already mentioned by Flores a few minutes ago, in order to validate declaration forms. And he'll refer to an experiment in the social security domain to assess SHACL's applicability. So, Christophe, actually the title here says application, so you're going to have to tell us whether it's applicability or application.
Applicability.
Good, so I was right. Thank you. Over to you.
Thank you. Thank you for the introduction. Hello everyone, the name is Christophe Debruyne and I'm here to present the work done by myself, Davan Chiemdao and Paul Stefhals. The title has been said, so let's get to it. So a little bit of context, SMALS carries out innovative ICT projects, mostly in the e-government and e-health domain in Belgium. And within SMALS, there's a research department that conducts applied research into novel technologies to see whether they are a good fit for their clients or provide new solutions to their clients. In 2021, one of these technologies were knowledge graph technologies, and that's when we started this study. And the study continued at, in the University of Liège by myself. So a little disclaimer, even though this study, we conducted an experiment in the social security domain, the Belgian social security was not involved. We have taken that domain because we had some domain expertise available to us in order to analyze and conduct the experiments, but also it is sufficiently representative of the challenges that SMALS, the clients of SMALS have, and lots of data are available, publicly available on the web. So what was the problem? Well, in the Belgian social security, employers have to report on employees entering and leaving the workplace. And they do so using a DIMONA declaration. And quite often they avail of an XML document to do so. Now, if you were to look at the portal, you will see that all constraints of the relationships and values and so forth are well documented in many glossaries and appendices. But even though they provide a XML schema definition document, not all rules can be validated using that XSD schema. The Belgian Social Security also provides a little Java program that tests other constraints, but not many of them. So it turns out that that the validation of such documents, such declarations, is quite challenging, and you have to submit those in order for the system offered by the Social Security system to analyze whether everything seems right. Moreover, rules are subject to change and may change every 3 months. Indeed, every 3 months there are new appendices, new annexes, and so forth. So there's a temporal aspect to these rules as well, which is great. So this allowed us to ask ourselves the question, to what extent can SHACL scale to validate complex validation rules, relying on a combination of existing SHACL constructs, logical operations, and, as we will see later on, embedded SPARQL queries, because we need to encode certain things using SPARQL rather than SHACL. So it's a typical, between quotes, knowledge graph project where we had to create vocabularies and schemas, populate the knowledge graph, enrich it, and ensure that its quality was up to par. And I will quickly go through the various aspects. Now, for the ontology development aspect, we didn't develop a full-blown ontology, but rather a vocabulary, because it was quite a simple domain. And we lifted the XSD schema into a vocabulary. So the XSD schema that was documented had a entity relationship diagram describing the XML structure. And there were about, I think, 26 blocks, 26 concepts, lots of relationships, and over 250 attributes. Now, once that was done, we needed to transform the data. And there were many sources that we needed to transform into the knowledge graph, by the way, using RDF. So the appendices, so here's a little screenshot of the portal, the glossarium. Unfortunately, no English translation. They're available in French and Dutch. And here there's a Dutch page, and they refer to the validation of that part of the XML document. They refer to a separate document called an annex, called an appendix. And within that appendix, you will find more rules that need to be validated. So what did we do? We transformed those appendices, which are available as XML, CSV, and PDF. We transformed the CSV files using the RDF mapping language, an initiative pushed forward by the University of Ghent. The declarations, which are stored as XML files, were also transformed into RDF using the RML language. And then one of the challenges we had to overcome was to organize our knowledge in such a way that we captured that temporal aspect. So that required knowledge organization. So for every 3 months, for every quarter, we have a different named graph in which we store the rules, because they are subject to change over time. Once that was done, it was up to us to develop the various SHACL constraints, which I deem also be part of ontology development, because you try to model your universal discourse and the rules that it should comply with. So the process was initially bootstrapped by just taking the XML schema, because many constraints were already there, simple constraints, albeit. And then once we have bootstrapped that system, we manually checked and completed and refined every possible rule, which meant going through the documentation, making sure that the documentation corresponds with what was encoded in the XML schema, but also whenever information was missing, looking into the annexes or looking at the descriptions in natural language, we just had to complement those SHACL shapes. Now, during this process, minor changes were made to the vocabulary to better reflect reality. To give you a very, very simple example, here is a page of the glossary where they describe the validation of the identification, if I'm not mistaken, the identification of a declaration form, because you can have forms that have different types, and you have to indicate what kind of form it is. Well, there are simple constraints that were made available using the XML schema to employers that we can easily map onto SHACL as well, such as checking the data type, the length of the string, and whether it is mandatory or not. So we can find those here in red. But then others, we had to consult either the appendices, or we had to read and interpret the rule or the constraints that were written in natural language. So in this particular case, we had to refer to Appendix 11, which gave us information about the various codes that we are allowed to use, but also when they are allowed to be used. And you can see that whenever it is set to the year 9999, it basically meant it's still in use. But there are cases where the date is set. So this unfortunately cannot be modeled with constraints, with the basic constraints and constructs that are available in SHACL, and we had to resort to modeling or creating those rules using the SPARQL query language, such as this one. I will not go into the detail, but basically it checks whether the code that is mentioned in the document appears in a set list, and whether it respects the temporal dimension, the interval of that particular type of declaration. Voila. So I think the most important message that I will now convey today are some of the lessons learned and the observations we had, because the code which is available will be provided via a link at the end of this presentation. So the observations, well, during this exercise, it turns out that very often very similar patterns emerged. And through prior studies, we already noticed that, okay, there is some common domain knowledge, common patterns that we would like to see made available in some way, shape, or form that relies on SHACL, but that we do not wish to recreate all the time. One of these patterns was checking various different checksums, using different algorithms and whatnot, checking intervals, whether a particular thing was within a particular period, and so forth and so forth. So, which begs the question: do we need to find a way to create those abstractions and share them? Is there a notion such as a SHACL design pattern and whatnot? And can we make them available using linked data principles?
Christophe, I'm afraid I'm going to have to ask you to run through your observations rather quickly so that we can take questions, because we have received some. It would be a pity not to have time.
Perfect. Okay, sorry, I thought I was within time. So data transformations in SPARQL queries. So can we have access to more, well, not useful, but better functions to do data cleansing whilst transforming or processing the data in those SPARQL queries? Then an interesting one was logical operator versus complex SPARQL constraints. While doing the study, we were able to either have many little constraints, and that's great for reporting back to the user, but creates a lot of computational overhead, or you combine them into one big SPARQL constraint that checks many constraints, less granular, but more computationally efficient. And this is a side note, has nothing to do with SHACL, but it turns out that sometimes the documentation was really hard to parse. Information was lost. They referred to checksums, but the algorithm was not made available, and so forth and so forth. And finding the domain expertise who could answer those questions was really challenging. Lessons learned?
I'm sorry, Christophe, I have to cut you here so that we can take those questions. But I think that you can share your slides afterwards. The first question we got was, did you try using schematron rules to complement XSD?
No.
You didn't. That's very straightforward.
Yeah, no.
Okay, and the second question we have here is, could you give a concrete example of a complex SPARQL constraint versus a simple one?
Yes, for instance, we had constraints such as if a company is in a particular situation, then the value must be 0, otherwise it must respect a certain checksum. So it was a case such as if this, then this condition should hold, and otherwise another condition, which brings me back to how fine-grained do you want it to be. So you can split it into 2 and then use a logical operator, but that creates much more overhead. We found that it was more efficient to have the one business rule embedded into a SPARQL query, so that only one SPARQL query was sent to the server and computed. But it's an interesting tension field, right? Because if you can decompose those rules in smaller units, well, then there's more opportunities for reuse and whatnot. But the computational overhead is quite substantial. So this is something we still need to reflect. I hope that this was a good example. I can share others if you want.
I think that probably answers the question. Thank you very much for being so clear and concise. And I'm sorry I had to cut you short, but we need to stick to our very strict timing. So thank you very much, Christophe, for being with us this afternoon. Thank you. Bye-bye.
Thank you. Bye.